Performance tuning in Linux involves optimizing various aspects of the operating system to improve overall system performance. Here are some general tips for performance tuning in Linux. Use monitoring tools. Utilize tools like Top, HTOP, Vimstat, IOStat, and SAR to monitor system resource usage, CPU, memory, disk I/O, etc. These tools help identify performance bottlenecks. Kernel parameters. Adjust kernel parameters, sysctl, to optimize memory management, network performance, and file system operations. Common parameters to tune include VM swappiness, VM, dirty_ratio, VM, dirty_background_ratio, net.core, and FS file max. File system optimization. Choose an appropriate file system for your workload, for example, ext4 XFS. Tune file system parameters for better performance, such as adjusting disk I/O scheduler elevator and enabling file system features like journaling and data write-back mode. I/O scheduler. Experiment with different I/O schedulers, for example, CFQ, Deadline, or Noop, to find the one that works best for your disk I/O workload. You can change the scheduler using tools like Tuned Atom or by modifying the kernel boot parameters. Kernel tuning. Consider recompiling the Linux kernel with specific optimizations tailored to your hardware and workload. This approach requires advanced knowledge and should be done cautiously. CPU tuning. Adjust CPU governor settings to balance between performance and power consumption. Common governors include on-demand performance and power save. You can change the governor using tools like CPU frequentals or by modifying kernel parameters. Memory management. Optimize memory usage by adjusting parameters like VM swappiness, which controls how often the kernel swaps memory to disk. Set swappiness based on your system's memory configuration and workload characteristics. Network tuning. Fine-tune network settings, for example, TCP buffer sizes, congestion control algorithms, to optimize network performance. Adjust parameters in /proc/sys/net/ or /sysctl.conf. Disk optimization. Utilize RAID configurations for redundancy and improved disk performance. Consider using SSDs for I/O intensive workloads. Monitor disk health and performance regularly. Application level tuning. Optimize application configurations and settings to make efficient use of system resources. Tune database parameters, web server configurations, and other application-specific settings. Regular maintenance. Perform regular system maintenance tasks, such as disk defragmentation, log rotation, and software updates to keep the system running smoothly. Remember to thoroughly test any changes made during performance tuning to ensure they have the desired effect and do not introduce stability issues. Additionally, document changes and monitor the system after tuning to ensure ongoing performance optimization.